This example is about a diver and the relationship between distance and time. So distance is a function of time, where s is the distance in meters above the water and t is time in seconds. So this value here will give you the distance above the water, and this value here is the time. So it's asking us to find the values over a given time interval, and the first time interval you're asked is, what is the average velocity between 1 and 2 seconds? And when we talk about velocity, that's the same as speed. And when we talk about speed is just distance over time. So think about when a car travels, we talk about how many kilometers you travel. Say you do 100 kilometers in an hour, and we put that as 100 kilometers per hour. And that's what we mean by velocity or speed. So the question is asking us, what is the average velocity of the diver between 1 and 2 seconds? So this is the height where he is above the water at 1 second, and this is the height he's above the water at 2 seconds. So how high is he at 1 second? Well, if I put 1 into there, it turns out that he's 10 meters high at 1 second. So this point here, 10 meters. And then at 2 seconds, if I put 2 into there, I find out that at this point here, this tiny bit here, it's 0.2 meters above the water. So the difference, this particular measurement here, is 9.8. Now the time between 1 second and 2 seconds is just 1 second. So to find the velocity, it's going to be 9.8 over 1. So it's 9.8 meters per second. But if you have a look at this gradient, if you look at this gradient, this is a negative gradient. Okay, so it's actually negative 9.8. Now I could have done that straight away with my using my formula. I could have said, well, the function of 2, what he is at 2 seconds, minus the function of 1, how high he is at 1 second, over the difference in the time, which was 2 minus 1. Okay, and that gives me 0.2 minus 9.8 over 1, and that gives me negative 9.8 meters per second. And that is the gradient of this line here that I put between the 2 points. The next thing they're asking is, what's the average velocity between 1.5 seconds, which is here, and 1 second, which is here. So again, we need the distance traveled over the time. Now the time's easy. This is just going to be 0.5. The difference between 1 and that is just 0.5. Okay, now what about this distance here? So we need to find out what the distance is here and here. What's that going to be? To find the distance at 1.5, I would have to put 1.5 into the equation and figure that out that way, because measuring it won't really be accurate unless I've got a really accurate graph, and that comes out at 6.32 meters. Okay, so we already know that this distance was 10 at 1 second, right? So what's this distance here now? That's going to be the difference between those two. So that difference, so this distance here is 3.68, and we know that this distance here is 0.5 seconds. So if we put that over the top of that, we end up, the value is 7.36. That's the gradient of this line. Remember, rise over run, the rate of change of distance over time. And it's a negative gradient, so it's going to be negative 7.36. If I put it into the equation straight away, I'd be putting the function at 1.5 minus the function at 1 over the difference in time, 1.5 minus 1, okay? And that would give us negative 7.36 meters per second. The negative just means that that's the gradient. Remember, he's diving into the water. The next interval they want is, what is the average velocity between 1.1 second, so from here to 1 here. So now we're getting closer and closer. So what is the height above the water there, and what is the height above the water there? So if I put 1.1 into the equation, I get 9.461 meters. That's how high above the water he is at this particular time here. At this one, we already know from before that it's 10 meters. So he's obviously gone, if the platform's here, he's obviously gone up a little bit and down a bit as he's gone into the water, because we know that the diving board is 10 meters above the ground, because at t is equal to 0, like at the very beginning, these two things cancel out, these cancel out if t is 0. So that is 9.461 minus 10 over 0.1, and that equals 0.539 over 0.1. This is negative, which comes to negative 5.39 meters per second. And that is the gradient of this line here, which you'll notice, because we're getting closer and closer together, is matching the curve more accurately. The next question asks for the average velocity between the time of 1 second and 1.01, which is really small. It's going to be very hard for me to see that on the graph. But of course I can just put that straight into the function again. And that gives me an answer of 9.95051. That's how high he is above the water at 1.01 seconds. And we know that at 1 second he's 10 meters above the water. So when I calculate that all out, this is the velocity between 1.01 and 1 second. So the next question is saying, okay, so what is the instantaneous velocity at 1 second? If at 1 second, how fast is he moving in the air? At 1 second. So how are we going to find that? Well, we can't find any sort of two measurements to subtract because we've only got one. So this is where we need to differentiate this equation. You'll notice that as we've been getting closer and closer to 1, we started here at 1.5, we've started at 2 and then 1.5 and then 1.1 and then 1.01. The tangents are getting closer and closer to being the tangent that's perpendicular to the point at 1, and that's what we're aiming for here. So if we differentiate this equation, we will get the gradient function. So remember the rules, we take this power, so that's negative 2 times 4.9, and then minus the power, that's going to be t just to the power of 1, and here we just end up with 4.9, because imagine that's 1 there. So now let's calculate that out. So we've got negative 9.8t plus 4.9, and what is that when t is 1? So that's going to equal to negative 4.9 meters per second at that particular point. But you see, using this equation here, this gradient function, I could have substituted any point to give you the instantaneous velocity. That's instantaneous velocity at any given point.